Okay, now we're going to look at homework 8, and in homework 8 we're going to look at prisms versus pyramids. All of these are what we call 3D. In other words, we're doing three-dimensionals. Area and perimeter were two-dimensional or one-dimensional. And the reason why is it's flat. But when we move into prisms and pyramids, we are no longer talking flat. We are now talking things like boxes, different size boxes. We're talking different size prisms. We're talking pyramids. So we're talking something completely different. It moves from flat to 3 dimensions. Has length, width, and height. So it takes all of that. Prisms are like boxes. Pyramids have a flat base, but go to a point in height. So they're very different from each other as far as how they relate. Okay? Now, we talked about perimeter when we talked about 2 dimensions. When we move into 3 dimensions, now perimeter, which is your distance around, becomes surface area because it's not just one line. Now it is a surface. So if we were to look at this particular prism right here, and we were to think of our distance around this prism, we would be going here. And what we've got is 1, 2, 3, 4 surfaces to go around. But we're not finished because you also have this end and this end. So you have 2 ends to get your ends on it, and then your surface area all the way around. So when we're talking this, now we're beginning to talk things like how many faces does it have? And we talk how many edges does it have? How many vertices does it have, which are the points where everything comes together. So we're talking a completely different kind of a thing. So the first thing you're going to do is look at all of those things when you talk about these particular kinds of shapes. And the other thing we're going to look at on this is the Platonic solids, okay? So Platonic solids are something that I really didn't know anything about either. This was a new idea to me, so I thought it was very interesting. Platonic solids have very definite requirements, okay? A Platonic solid. So what is true about a Platonic solid? Number 1, it's 3D. In other words, it has to be 3-dimensional. Number 2, each face of the solid is a regular polygon. In other words, what is a regular polygon? A regular polygon means that all sides are the same length. Okay, can we think of some of those that would be true? Well, a square. All 4 sides are the same length. How about an equilateral triangle? That's another one where all the sides are the same length. So those are just 2 of them that will go into this. There's one more shape that actually shows up, and it is a pentagon. a regular pentagon, which means all the sides are the same length. Okay, and what's the last thing that it requires? It requires that each vertex has the same number of polygons meeting at that point. Okay, so those are the requirements. Now here's what's interesting. There are only 5 of these Platonic solids. There's only 5 out of all the various shapes we could have. There's only 5. So, very interesting. I went online, and these are going to be part of your activity. What I want you to do is I want you to take these sheets of paper, print them out, and then cut them out so you can start looking at the Platonic solids by hands-on tools. So, I cut the first one out. And as you see, when you cut it out and then you fold it, if I were to tape this together, it makes a triangular figure like that. And in fact, this particular triangular pyramid happens to also be a Platonic solid because all 4 of my triangles are the same. Okay? They're the same shape, exactly the same shape. And so therefore this happens to be a Platonic solid. But you can put these together, and when you put them together, now you can count your vertices. In this one, it is 4 vertices. And how many faces do we have? 1, 2, 3, 4 faces. And how many edges? 1, 2, 3, 4, 5, 6. So this one has 6 edges. Okay? The names of these Platonic solids are based on the number of faces they have. This one has 4 faces, so this one is called a tetrahedron. Okay? A tetrahedron. And that tetrahedron, as you can see, is made up of 4 faces, 4 vertices, 6 edges, and 3 triangles meet at every single vertex. And every one of them has exactly the same. So this is a tetrahedron. And your exercise on this, you will print out a chart that you'll have to go ahead and fill it out and label all that information that I just did for this one. You're going to do for every one of them that you have. And you've got papers on every one of them. The name is on it. So you will be able then to know what it is you're dealing with, and you can build them. You can see exactly what you have. I think you'll enjoy that. You'll actually probably remember it longer than if I gave you that information, but it'll be fun for you to do that, okay? Now, what if we wanted to know the surface area of these things? That's not so easily done. The one that's a cube is easily done because it's just squares. This one happens to be a octahedron. What is that called? I always forget the names of them. Yeah, this is a hexahedron because it's 6-sided. So this cube is a hexahedron and it is 6-sided. This one wouldn't be hard to figure out. Why? Because it would be each one of the squares would be exactly the same. So the hexahedron it would simply be 6 times the side squared. That one's an easy one to calculate. The others are not so easy to calculate. So I went and did some research so I could find out what would be an easy way to calculate the area of an equilateral triangle. And the reason why is triangles are actually the base for more of the 3 out of the 5. So that means the triangle, an equilateral triangle, would be very helpful to know. So the area of an equilateral triangle is the square root of 3 over 4 times the side squared. So all you need to know is the side measurement of the equilateral triangle, and you can calculate the area of that equilateral triangle. The other one is the regular pentagon, because one of them, the shape that's based on it is a pentagon. So a regular pentagon. And how do you find the area of a regular pentagon? Well, here it is. And because you guys don't know about tangent, I changed it. But the official one is 4 times the tangent of 5 over pi times the side squared. Turns out that that's equal to 5 over 2.9 side squared. And it's not exact, it's a little bit of an approximation, but it's close enough. So if you were to figure the surface area of a pentagon, it would be 5 over 2.9 times the measurement of the side of that pentagon squared. And so if we how many pentagons are in, how many faces are in the one that uses pentagons, that would then give you your surface area. And we'll look into that more on the next lesson. So that's the end of lesson 8.